Ďakujem, že rešpektujete dochvíľnosť. Na margo dochvíľnosti mali vždy
Thank
ako vždy.
you for being punctual, and I also have one joke about this. Punctuality is the feature of kings. I was born with C-section, therefore I can be late. So we are about to start, and before I invite another speaker, who I'm very looking forward to really a lot, you can join our competition. The lady behind there, I've been watching you for 2 presentations. If my wife knew that, that would be scandalous. So you can register, and we will compete for a car, hybrid car. So you can take time, and maybe you will be lucky and you will be driving home or something else. So Mr. Jiří Dědeček, who is a researcher and head of structure and dynamics in catalysis department from the Academy of Czech Academy of Sciences. He was at Hierovský Institute, who was one of the first people in Czechoslovakia who received a Nobel Prize for chemistry and physics. So this is something I accidentally knew. We also have everything in our heads except for the information. So this is regarding your job, and the topic of your presentation is green transition through eyes of physics and chemistry. Your presentation drew a lot of professional and general attention. They say everything regarding the energy is already solved, and in decarbonization we have all the solutions done, and everything is in Green Deal. So is it really so? We will see. Mr. Dědeček, the floor is yours. The guys will turn on your mic. You just need to speak. Can you hear me? Good morning. Before I joined the competition for most depressing presentation of the day, I would like to thank the organizers, because I'm here as a Czech and I'm very envious to you. So let's start with my presentation. Don't be afraid of physics and chemistry. You just need the level of knowledge from the high school. I know for some it's maybe too much, but don't be afraid. It was already mentioned that I'm going to talk about the green energy transition. We will speak about the decarbonization. As you can see, we have a lot of ambitious goals at this presentation because we have a limited period of time. So let's move on, because we don't want to end up as the guy on the picture, because it's the most stupid situation to be somewhere and cannot go further or back. So we will speak about the defossilization, decarbonization, carbon neutral economy, and elimination of anthropology and greenhouse effect. So we will speak about the scalability, about critical materials, and then when speaking about energy sector, we will speak about ROI, how much energy is returned on energy we invested, so that this number is much bigger than 1. And then we should also assess the whole cycle of the certain phenomenon, so that we can achieve some sensible conclusions, and still be aware of the physical laws during the presentation. Those cannot be avoided, neither avoided nor amended. So I have even was asked whether thermodynamics can be avoided, really. So first problem, I don't know what about Slovakia, but in the Czech Republic, this was focused especially about electroenergetics. However, electro makes up around 18%, which is quite good, not a bit worse than in Slovakia, but the problem is not terrible. The situation is as follows. Energetics, however, includes everything else, so the transportation and so on, and then this issue is like eight times bigger in Slovakia, 6 times bigger, so we should be able to solve it thanks to nuclear, to biomass, and also to and also other energies. So for that we need, in the Czech Republic, we need 48 terawatt hours per year. In Slovakia, you divide these numbers by 2 terawatt hours. Nobody can imagine that. Therefore, I use unit 1 temelin, which is approximately 2 gigabytes. And for you, 1 gigawatt is the performance of 1 Jaslovské Bohunice plant. So those are nicer figures that we can imagine better. So let's start with alternative solution, which we have here in Central Europe. If we see this from the energy point of view, we will not solve it. We would need more than 28 nuclear power plants. You only need 20, depending whether you consider Mochovce or Jaslovské Bohunice. However, already at this moment we have the limitation of resources, because we need cooling water also in summer, and also staff, because to get people who will operate tens of power plants is out of capacities of our education system and the population as well. When speaking about municipalities, well, everybody is happy about modular nuclear power plants. However, be aware that Rolls-Royce and their modular power plant has the performance of 370 megawatt. Jaslovské Bohunice had 440 originally. So those small ones are basically your normal nuclear blocks. Dr. Drabova, who was deceased lately, summarized it very clearly. Nobody will build anything because this will not go through the population. So let's forget the nuclear. When we check the photovoltaics, it would look nice. In the Czech Republic, we only need 6% of the area, but it's a crazy number. I don't know where we could find it, but it's average. Of course, we want light when it's dark, we want heat when it's winter, so therefore we would need more than 50% of the Czech Republic area to have covered by photovoltaic panels, and the photovoltaics can work 15 to 20% of time. Therefore, you need to ensure the energy for the rest of the time. And there is always this hope in science that the scientists can improve it. However, they will not, especially not significantly. I'm sorry. Another issue or another solution is the wind. You can generate here any number and it will be true, because the energy of wind depends on the third unit of its pace and velocity. So it depends how much performance or how much duty you need, so the numbers will change. And if we count it for Slovakia, in the Czech Republic we need half of the republic. In Slovakia it's a bit better, but it's still very problematic. And there is a short use of time, around 20% or 25% of the time of the year, usable time. If you check this map, this red is the big wind duty, and if you check the protected area, it's basically the same as in the Czech Republic. In the high Tatras there is a good wind, however you cannot construct any power plant there, and the valleys will not be sufficient. Biomass, that's something we don't even need to talk about, because we would need to cover our energy 100 annual loggings in the Czech Republic. In Slovakia you need 50, however it's still not possible, and we need 1 to 5 times area of the Czech Republic to be able to plant this mass. I don't know whether you believe in perpetuum mobile, but we would need something like that, because on the entire area of the Republic we produce this energy in biomass. Somebody needs to plant it, somebody needs to process it, biodiesel and the plant energy, and you just get 1.2 barrels of the fuel. And with biomass there are further environmental problems, such as a loss of soil carbon, loss of chemical properties, and then the rules are there completely different when it comes to chemicals. So there is a problem with renewable resources, and that's the entropy problems with their internal problem. So if we check the density of energy in photovoltaic, wind or biomass, so we speak about gigawatts per square kilometers, and if we speak about the filling, it's 10 megawatt. So these cars use the same or produce the same duty as the entire Jaslovské Bohumice power plant. So no matter how you count it, the energy from renewable resources, except for being timely limited, must be very much concentrated. And this is the problem or issue which in Slovakia and the Czech Republic is not so significant, because we all know what is Cinderella. We know how the stepmother mixes the peas and the lentils, and we know that nothing really happened to those. However, there is a mess, and therefore to clean up that mess you need to produce some duty. And it's not only this generalized energy, but also this mess, and this costs us a lot of energy. That's why gold is so expensive, because you have to concentrate it 80,000, 100,000 times from the golden sand, and you want to get the gold itself. So that's why renewable resources, where the energy is scarce, cannot really achieve the high energetic productivity, and therefore it's very problematic to use it as energy resource. So if we don't have nuclear, biomass has no sense. Renewable resources can cover us 40% of the year with very low efficiency. So with photovoltaics it would be even in the negative figures, and the energy resource cannot really function properly, only under certain conditions. So what to do? The energy needs to be taken, stored and brought from somewhere, because most of the time we will not be able to produce it. And when we speak about inversion situation, this is very improbable, because we cannot rely on the fact that Spain would basically give the resources to entire Europe. So what we have to do, we have to store the energy. Sorry, it's not working. So, if I store the electric energy, because we cannot really produce any other from the renewable sources, the best way is the pump storage power station. But we have to be ready for winter inversion, which can during winter last even up to 3 weeks, and therefore in the Czech Republic we would need 13,000 divided by 2, and you would need 6,000 pump storage power stations here. The second option is battery storage facility. In the Czech Republic, when we have the winter inversion, we need basically, with the current lithium batteries, we would exceed the storage of manganese and cobalt. So we would need half of the reserves. However, it cannot really work. Lithium battery will not really improve much, only a few tens of percent, but not significantly. Therefore, we would have to import energy. However, it's not a big deal because we are already doing it in the EU. However, we should find good sources, because biomass, the import of biomass from the world would be basically an environmental crime. It would be close to ecological colonialism. So, and how could we transport energy, which is very expensive, and I cannot imagine this cable from Australia, because Ohm's law can be amended by the EU, but it will not help. So there are technical issues regarding the transport and storage of energy. Therefore, we need to have some sensible solution, and that's the chemicals, so the chemical bonds, or energy in chemical bonds. And this is the very popular topic, and that's hydrogen. However, there are a few issues. We cannot do that. That's the first one. We produce hydrogen for 140 years, however, as a commodity, not as an energy feed. And that's the problem. We can produce it, but only by iridium electrode, because everybody can produce hydrogen. That's not a big deal. The problem is that except for hydrogen, you need oxygen, which is a much more complicated process. And for us to have it efficient enough and to be able to manage the fluctuating delivery, the EU would have to purchase the entire iridium available in the world for 12 years. So this does not work as well. Here I'm being optimistic, because we need to get from here to here, and theoretically it's possible when we have, let's say, highly anthropic alloys of metals. It's possible to do it without iridium. However, nobody has managed this yet. We're working on that very much, but not with much success. And when we learn to produce hydrogen, we will discover that it has a very low volume density of energy. Therefore, we cannot transport and store it. Therefore, you have to liquefy it, and this is very complicated because the temperature for liquefaction is very low. So we cannot really do that. So if you check this proposal to build hydrogen power plants, for the For the you only need 15 kilometers for the transport. However, for the storage, you need 300 kilometers, and you have, because you have these losses, and how you store 300 kilometers of hydrogen. That's a very interesting question. And even if we manage all of this, we have another problem, because hydrogen is a greenhouse gas. If somebody is educated in chemistry or physics, it is the molecule that is unable to absorb infrared lights, so it cannot really function in this sphere, and it basically disseminates to the molecule of oxygen. However, it's a completely different OH. It's a radical gas. And radical chemistry is very interesting and popular among chemists, but it's a very reactive material, and under current conditions, these radicals clean the atmosphere from everything possible. The most frequent chemical that cleans the atmosphere is methane, because methane is very common, and when we start producing hydrogen, start with hydrogen economy, that will, however, escape a lot, because it's a tiny molecule. It can go through metal, and then it will react with these radicals, and we will only be left with methane in the atmosphere, which is a strong greenhouse gas. And as the hydrogen does not absorb ultra-red light, it will be much more efficient as the oxygen. So it will mean that we have now limits and permits for CO2, and then we will have to do the same with methane and its emissions, and then we will find out that it's even not possible, and left without solution. So hydrogen economy is nonsense. The only thing we can produce is the hydrogen. So we have to produce something else. First candidate is ammonia. That is great, has a great density of energy, and it's not a greenhouse gas. But that's the only nice thing we can say about it, because the effects of ammonia emissions are huge. I mean, it's 96% of conversion and 90 to 95% of selectivity. There is a huge risk for transport. Even I'm worried when we have it in the lab, and this is a huge risk of accidents. So if you to build some pipeline for ammonia through Poland or Czech Republic to Slovakia, this is something I cannot imagine. So therefore we have to produce something else, and those are carbon fuels. Those are very sensible, we can work with those, however they will be fossil, and it has one prominent problem, and it is that we cannot do it. Because if you consider the criteria that we need energy balance, those should be very efficient materials, and this is something we cannot do. We are producing, let's say, methanol, or also the carbon hydroxide, but we did it during the Second World War, but at that time the coal was not a question. So to make it more sensible, we should take the 3/4 of this hydrogen, which is very expensive, because to get methanol, or you need to somehow get rid of the oxygen. So the result is that if they have some facility in US, South America, the production price is around 20 euro. So you can count how much it would cost us if we started with it. And the entire efficiency of the storage of energy is very low, and it makes no sense. We can try something else. For example, to get the methanol from methane, we are trying new processes, but that will only give us 50% of hydrogen. This is still not sensible. We can try electrochemical reduction, direct conversion of CO2 to hydrocarbons. However, we cannot really do that. We are still researching, and maybe we'll learn it in like 25 years. The only thing we can do is we can draw subsidies, companies can do nice greenwashing, and that's all. Because China would take only like half of Australia only to be connected to photovoltaics. Therefore, we implement Green Deal, and we stop somewhere, as this man on the picture, and we are not able to store it in a chemical bond, and we are not able to ensure the reserves of energy. Therefore, we come back to pre-fossil period or time, and this is where we always speak about the risks of a global climate. We are not talking about positives of fossil fuels. So let's come back to history of, let's say, 1840, where there was lower life expectancy, higher infant mortality. I mean, we have already tried it, and it was not good. So, and we cannot really do this, and all of these are is dependent on the sufficient amount of energy that we can use. We are not going to get anything for that, and if we see the prediction by OPEC, who put money into this, until 2020, until 2050, the fossil fuels will have increased use by 20%. So if I conclude it, the emission-free energetics based on available technologies is not possible. And if we try to do it in Central Europe, we don't even decrease the CO2 emissions. However, it will not be in upcoming time possible without nuclear energy. We need to manage what we are not able to do, to store the energy in chemical bond, and to the very end, I would say, climate change will occur. Whatever we do in Europe, or if we do nothing, there will be climate change. So why this conference is happening is what we should really do. I mean, climate change will occur, so therefore we have to adopt, and that's what you do, which is great. And instead of fighting for no reason or uselessly, we should find at least passive solutions, because energy will not be, or we will have a problem with the energy supplies. So therefore we need solutions that are resilient against the collapse of the resources. And I'm sorry for damaging your appetite, but maybe you are not worried about the future, but this is how it is. You don't have to be sorry. This was the most beautiful, depressive presentation I have seen over the last years. It was great. So much romanticism and realism I haven't even seen in literature. You should start writing. So we are not afraid of chemistry or physics. I got lost after your sixth sentence, and I knew that I have some shortcomings in my knowledge, but it's okay. Yes, but okay. Again, also with Mr. Dědeček we will speak at the end of today's presentations, because all of our presenters will have a